The topic will be building faster, stronger, and safer buildings. I won't go into too many details into that, as I would like to call Engineer Harrison Lockhart, who will come and bring introduction of our guest speaker.
Good afternoon again.
Good afternoon.
Mr. Dave Burtt is the Vice President of United Stated Operations. He joined MgO Systems in 2017 after over 25 years of experience in home building industry in the United States and in Canada, both working in senior management roles for large builders and as former owner of one of Alberta's premier custom home builders. Dave is a certified master home builder through the Professional Home Builders Institute of Alberta, which is PHBIA, and is a former member of the board of the PHBIA. Dave is the recipient of numerous SAM awards, now renamed the BILD Awards, as one of the top home builders in Alberta. Let us welcome Mr. Dave Burtt.
Thank you very much. Thank you, everybody. It's a pleasure to be here. Everybody hear me okay?
Yes.
So first off, I just want to say just how much I'm enjoying this beautiful island of yours. I actually am a Canadian citizen by nationality, and we moved down to the Palm Springs, California area about 2.5, 3 years ago. And so I'm accustomed, although we don't get the cruise ships that you guys get, I'm accustomed to all the tourism and whatnot, and I can only tell you that, you know, my coworker Dewey, who lives here in the island, took me for a long tour yesterday of the island, and we plan to spend another week here as vacationers after this is all over. So, thank you so much. So I want to introduce you to MgO Systems. We call it a better way to build, and I just kind of want to go into a bit of the history of MgO, how we started, why we started, and why we say it's better. So MgO was literally born from the ashes. The founder of our company is a gentleman by the name of Todd McKay, and I'll show you a picture of him later. But about 7 or 8 years ago, he lost his home to a fire, and it was just due to the time of day. It happened about 2 o'clock in the afternoon. The fire was a garage fire. The house is gone in about 3.5 minutes from the time it caught. It started in the garage. The garage there is bedrooms located above the garage. Had that fire occurred at 2 o'clock in the morning instead of 2 o'clock at night, there had been loss of life. And so at that point in time, Todd just said there's got to be a better way to build. So this is a picture of Todd. He's our founder. He's a master electrician. By trade, he's run electrical contracting firms pretty much his entire adult life, and then started MgO Systems about 7 years ago. Scott Jenkins is our president COO. Scott's worked for a company called Burtt Environmental Solutions. When he was the president of Burtt, he led it from a $20 million a year company to a $300 million a year company in 11 years. I'm sorry. And Scott is now our president and COO. And of course, there's me, the most handsome of them all. So I kind of want to talk to you guys about the C3 engineered wall system. So that is what we are. We call ourselves an engineered wall system. And a lot of you have heard the term SIP, structurally insulated panel. And I want to kind of explain what the difference is between a SIP panel and our system. And so, as I move away from the mic, everybody can still hear me?
Yes.
Yeah. Okay. So this is how we build right here. Sorry, this is how we build. But this would be a traditional steel frame construction building. So we are, this system here, which is us, we are a light gauge steel building. But we build everything within our panels. A typical SIP panel would be this or this minus all the steel, so there wouldn't be a whole lot of structure in it. And so if you look at the way that steel framing is done currently today, what they'll do is they'll put the bottom track down, they'll stand up all the steel, they'll put the sheathing on one side, then they'll fit the bats, the insulated fiberglass bats in between the studs, then they'll sheathe the other side. So we do all that exactly the same, with the exception of we do it within a plant, a warehouse. And then the big difference for us is we use a magnesium oxide board, which is this. It's a cementitious, it's a concrete board. And the advantages to using that over, say, typical drywall is we're completely non-combustible. We've got a Class A 1-hour fire rating. We are mold and mildew resistant. So the magnesium oxide is a mineral. It's mined out of the earth and turned into concrete. And then we turn it into boards. Now these boards are just 1/4-inch boards. It's just a sample. Typically the board we use would be a 1/2-inch board for our construction. But there are applications where a 1/4-inch board may be all that we require. And so that's a C3 engineered wall system where it's a complete package. All the steel and everything else comes right from the factory. So we're rated and tested with our 10 style compressive, traverse, and shear capacities. We get ratings all the way up to 1,600 pounds per foot. And then so we're showing 540, but that's with an error factor of 3. And so we can safely boast that we're 540 pounds per foot with diaphragm shear. Completely H2O tolerant. So we're ideal for high moisture and flood-prone areas. We won't rot. We won't harbor mold or mildew. So you could literally submerge us in water, a sheet of our board in water, dry it out, and install it on the side of the face of the building. That's no problems at all. Easy to work with. It's kind of just like drywall, with the exception of it's a little heavier than drywall, with the exception that we're a cement board. Unparalleled fire protection. It's one of the interesting things about our board is that if you light a torch to it, it'll actually, the first thing that comes out of the board when you're laying a torch to it is moisture. And so, because there's water and concrete, it starts to revert back to its natural state when exposed to flames for a prolonged period of time. So the board is actually fighting the fire naturally. Small carbon footprint. We're truly a green material. We're mined from the earth to make a magnesium oxide concrete as opposed to a Portland cement concrete. We are fired at a much lower heat, and so quite a bit greener. So one of the things we did here in the last little while, so in 2017, in April of 2017, we commenced a 40,000 square foot school located in Tampa, Florida. We commenced construction of the school in April of 2017. We had children running through the halls in September, or early September of 2017. A week after we opened, we were hit by Hurricane Irma at full force winds. Now our system was engineered and designed to withstand 155 mile an hour winds. That was the criteria of the jurisdiction that we were building in. We were hit by Hurricane Irma at 110 mile per hour winds. We were the only structure in the vicinity that had no structural damage. None. We had a couple broken windows from some flying debris, but no structural damage at all. Everything was intact. So this is a letter from the engineer who designed the building. But I can tell you, we all sat there as Hurricane Irma approached, we're going, oh my goodness. But it performed exactly as it was designed. Safer. So safer and better. So zero flame spread, zero smoke contribution. So you can light a torch to us, there's no smoke comes off this. Fire rated 1 hour, ASTM. And we can give you a wall that's got a 4-hour rating. Fire, smoke, and thermal separation between adjacent spaces. And we can actually build without the use of sprinklers. And so sprinklers are coming into play in building codes right across North America. I'm not sure what it's like in the Bahamas for sprinklers being mandatory. But because there's nothing for us to start on fire, you negate the requirement for sprinklers altogether. So here's a firebox test that we did. So the inside of that temperature of that box is 2,030 degrees Fahrenheit, and there's no burn through after 45 minutes. And that's just a half-inch sheet of MgO board. So we've got all the testing, all third-party testing from ICC, Intertech, ASTM, pretty much everything. And so whatever you need, we can satisfy. Healthier. So people have heard of sick building syndrome, I imagine. Sick building syndrome a lot of the times is caused by mold that you get. Now mold is something that when you get a high humidity area, probably like the Bahamas, you probably get mold growing naturally in most buildings. Because we are a mineral-based product, natural mineral-based product, we do not get mold, and that has been tested. We do an ASTM rating for mold resistance. Because we're cementitious or a concrete-based product, we're impervious to termites or rodents, or we're not a food source of any kind for bugs, termites, rodents, whatever. Another real key feature for us is we've got no off-gassing. So you look at OSB or plywood. Plywood's a series of laminations where it's just laminated like that using glue. And there's a lot of people who are very sensitive to the off-gassing of the glue, and especially if a building like that was to catch on fire, because now we create a toxic smoke because the glue is not all that friendly. So we've got absolutely no off-gassing period. It's kind of the same thing. These are just some of the reasons that no off-gassing. So EPS is the polystyrene system that we use. And I've got a sample of our board minus the steel structure that I can show you. But MgO boards are used they're inert mineral compositions and no off-gassing. So something interesting about us as well is the fact that MgO board, we're designed for a 100-year life cycle compared to a 40-year life cycle of modern stick build construction. Now down here I imagine you use a lot of block and whatnot, but so we'd be along the same category as block. The big difference we have between us and block is our insulating value. And so we have very, very high insulating value. We've got very high thermal values, and I'll show you a picture here just further in the thing, in my presentation about that. Job waste. Because we're manufactured in a factory, we come to site, and there's very little job waste just because all the panels are meant to fit together, kind of like a Lego block. So they just go together, and just one panel to the next. When we manufacture, we're manufacturing a 1/16 of an inch. So we're very, very straight and true. We did a building in southern Alberta. It was a motel. It was a single-story motel that was 310 feet long by about 87 feet deep, I think it was. Over the course of that 310 feet, the height variation was 1/16 of an inch. So we're completely square, completely straight, completely true. All the trades that come after us, cabinet makers, they just absolutely love the fact that they can build a 90-degree cabinet. It'll fit in one of our 90-degree walls perfectly. And for those of you who might have had experience with home building, you'll all understand that that isn't necessarily the case with home building. Anyone who's interested in LEEDs, so LEED is environmental. It's an organization or something trying to achieve that gives you shows real green building initiatives. And so our system gets you about 36 LEED points, and I think the minimum for LEED to get certification is 40 LEED points. And so we're 9/10 of the way there for you already without doing anything else. So built to last. Here's two structures that were built with MgO, magnesium oxide concrete. It's the Great Wall of China, built in 2006 BC, and the Brooklyn Bridge. that opened in 1883. Those are all constructed with using magnesium oxide concrete. So here's the lead points in the various categories, and I can certainly answer questions more to that for anyone who's got questions on that. But ultimately, we improve energy performance for new buildings. So when you put us up, we're literally considered a net zero building because we're airtight. You'll need to have some sort of air exchange system in there with us. We're environmentally friendly. We improve indoor environmental qualities, and it's a preferable way of using materials and resources when there's no waste. And also points for innovation. Thermal comfort, I'm going to show you a picture here. So back in New Year's Eve on 2017 in southern Alberta, the temperature was minus 50 degrees Celsius, which is equivalent to minus 58 degrees Fahrenheit. We built a garage that was left unheated. And so the picture you see on the right is the thermostat in Fahrenheit of the temperature inside that garage, where the temps outside were minus 58. There's a 92 degree swing. And so essentially, the thermal capabilities of our board, it doesn't let the cold air in, nor does it let the hot air out. You can downsize your HVAC systems by probably 35 to 40% using this type of system, just due to the thermal capabilities and the performance of the system itself. Faster. So because we are a panelized system constructed during a time when you guys are applying for permits and all these various things, we show up to site and we're ready to erect. And so there's a group out of the US called RS Means, and RS Means did a site-to-site comparison. Now in this case they use stick frame, but I think stick frame is probably a little bit quicker than block. But we were 55% faster erecting a building than typical stick frame. And so that school that we did in Florida, for example, we put up a 40,000 square foot school in just over 2 weeks. So the 41% less expensive, what it refers to is labor. Our system's actually more expensive than a typical stick frame building, but the speed at which we stand things up, you actually save quite a bit of money in labor. And so when you start factoring in all the pluses and minuses, we're not that far off from typical stick frame. We're probably within 10% on the whole project. Acoustical performance now. STC is really important. You come to hotels or labs or certain areas. We've achieved STC ratings all the way up to 69. Our standard materials probably somewhere around the 40. Just a simple half-inch wall, 6-inch EPS, and another half-inch sheeting. So we're right around that mid-40s just as our standard, but we can do things to increase it even more. So some of the things we do, so we build non-combustible homes. So if you think of all the wildfires that were burning down in Southern California last year and the year before and the year before and the year before that, so it seems every year it seems to be burning down homes. We actually had a home, and it was covered on KTLA News, which is a major evening news for Los Angeles. And they actually showed a home. Now, we didn't build it, but it was a magnesium oxide home. The fire swept through a community. There was one house left standing at the end of the time, and it was an MgO home. All the other homes burnt to the ground. Now, I'm not so certain, when you go back, you're overjoyed that your house is still standing, but then you kind of look around at the devastation. I'm sure that's pretty shocking to most. But if the whole community had been rebuilt or built with MgO, and you have a windswept fire like that, the fire just passes over. So say for multifamily and office, we are really passionate about fire safety, and we're really passionate about healthier buildings. And so mold and mildew mean a lot to us, and fire safety in homes means a lot to us. You get a nursing home, assisted living facility, a memory care facility, and if a fire was to start in the mechanical room, the fire would be completely contained in the mechanical room. But the firefighters would still evacuate all the residents. They'd have 2-3 hours to get people up. So it was a typical stick frame construction where you've got stick frame in the walls in the basement or the lower level or where the mechanical room is. You don't have 2-3 hours to get people up. And so we're really passionate about that. Warehousing, we do a lot of warehousing, but probably the biggest in medical facilities. We're just quoting on a 1 million square foot facility in Riyadh, Saudi Arabia right now that it looks like they're pretty committed to going with us. Healthier schools. We're currently putting our system through ballistic testing so where we can actually make schools safer. So you get, like in the US, where you get these crazy shooters. All you need to do is go inside the classroom, lock the door, and you're safe. So those are the things we're working on. Greenhouses, we're doing a ton of greenhouses right now, and it's just due to the high humidity of the greenhouse itself. And so because we resist mold and mildew, a lot of the greenhouses nowadays they're doing plants and whatnot that are for medical uses. And they can't have mold or mildew, or otherwise they'll lose their whole crop. And so we're seeing a lot of our product used in those applications. I'm currently working on a big project in North Palm Springs. It's called Coachella, and it's a 160-acre park, and we're doing all the buildings in it. So there's probably $3 or $4 million, or 3 or 4 million square feet of buildings to do in total there. So transforming water construction. So this is just one of our brochures. Now I've got these little USB drives or memory sticks up here on the table that you're welcome to have, and they've got our brochures on it. They kind of just go through the attributes of our system and whatnot. But the top picture you see right there, that's the Avant-Garde School done in Tampa, Florida. And that's more of a rendering, obviously. It's not a real picture, but that is indeed what it looks like. And that's a school that was hit by Hurricane Irma, and that's like a couple of broken windows, and that's it. But we also do housing. Pretty much anything you're looking to construct, we can construct. So a better way to build schools, that's also one of the brochures up here. And that's it, folks. I'm here to answer all your questions. And yeah, no, go on. I just came up with an answer.
So, any questions? Can't say answer. It's
Yeah,
stuff.
so you do a full building system.
Correct.
Because there are other systems that make up the building. I mean, you have the roof.
Yeah.
So you do the roof also.
Yeah.
And then you have mechanical, electrical that goes in. You do that also.
Yeah. So this is kind of just a sample of our system right here. So you've got the 2 pieces of MgO. Now typically, this is just my little traveling sample. This shows a 1/4 inch board, but typically this would be a 1/2 inch board, and the EPS in the middle would be a 6 inch EPS. But we actually run channels through from top to bottom, and that's how we run all of our electrical through our boards. And then you can cut this just as easy as you can cut drywall. And so we just cut out the chase or the electrical box that we want to put it in, run down wires. And we're also at the point where in the next couple months, we'll be able to ship you all the panels with the boxes, electrical boxes already installed, and all the wires. And we'll put an end on it where it just plugs into a manifold, and so you just go live like that.
So you would do the design, or you take the design from an architect?
Yeah. So how it works for us is we get a design from the architect, and then we'll take that architect's drawings and we'll panelize the whole drawing to match the architect. Now, typically what we like to do is work with the architect when they're starting to draw, so to make sure that, for example, our typical exterior wall will be a 7-inch wall, so it's got 6 inches of EPS, a 6-inch steel stud, and it'll have 2 half-inch sheets of MgO board. So it'll be a total of 7 inches. So if we've got architects that are designing for us a 7-inch wall, then we'll match them exactly.
Any other questions?
Craig, the panels, what size do they come in, or are they engineered?
They are, so we're doing a building right now where the walls are 18 feet high. Now our panels themselves are 4x8s, 4x9s, and 4x10s. But if we've got an 18-foot high wall, we'll actually do what they call a jumbo panel. So we'll actually build the panel to be the exact height of the building that we need it to be. And then then it'll be like a tilt up. We'll stand it up on site using property type. And that's how we do our roofs as well. So we've done a school in Florida it had a 72-foot span. We had a center beam going across the middle. So we did two 36-foot sections, and we just took a crane, just hoisted them up, put them in place. And we went. So that's probably one thing to reiterate too. So we are a completely engineered system. We engineer our system to match the jurisdiction which we are here. So I understand from Julie that here we'd probably have to engineer to be 200-mile-an-hour hurricane winds. And we can do that. We'd probably use a heavier gauge steel, so probably get down to a 14 gauge. We'd probably be 2 foot on centers. But we actually have an engineer that's out of Florida. He's licensed in the Bahamas. He's done a lot of work in the Bahamas. And so we'd engineer to withstand 200 mile per hour. Yeah.
With respect to finishes, is it finishing the same way as a typical sheetrock wall, or do they come finished?
No, they come just like the little samples that we're making their way around. That's how it comes. But we do have, and to finish it is different than a drywall where you use drywall, mud, and tape and stuff like that. We've got a product that is acrylic-based. It's kind of like acrylic-based sand. That's our seam filler, and that smooths everything out. Now, the beauty about the acrylic base is it's got high elasticity. And so we can get that, and it'll harden enough that doesn't bounce out, and then we can paint it. And so we can give you a coat that's it's like a paint grade or a stucco grade. Also interesting about this is no moisture or vapor barrier requirement. So this is actually goes into onto the ground and
I see it's got it. Gardner?
Size of the atmosphere condition, but it's time and the atmosphere condition.
yeah, it's impervious to water, and that's the big one, right? Water's the big one. And so, once you paint this and everything else, we're completely sealed. We're a sealed system. Yeah.
Raquel?
Yes, I guess you can use the walls with a conventional foundation system.
Yeah. So are you talking like a block
Yeah,
foundation
wall
system?
foundation system.
Yeah, we could stand up on top of a block wall.
Okay, and any connections and the system pulls or puts together, are they like galvanized, or what type of material do you use to connect if you were to?
So we typically use there's a small percentage of chloride in here, which chloride can be kind of a corrosive material. And so what we recommend for connectors and screws and stuff is a coated screw. Some systems are a stainless steel screw is required, but not for us. A coated screw is plenty. For connections for tying trusses down to roof or down to walls and whatnot, we'll use a Simpson tie. Yeah. And it'll be 100%.
I asked the question because of the high salt content here.
Yeah.
In terms of corrosion.
Yeah, so we use a coated screw. And a coated screw will have, I think our coated screws are like 2,000 hours. So they've got tremendous resistance towards chlorides.
Mr. Butler?
I have a question. What is the costing of something like that per square foot?
Well, that's the challenge. And one of the challenges we have in quoting a number is it depends upon, in Southern California, what I'm engineering towards is 135 mile an hour winds, but also Class E seismic. And so the 160 acres that we are building on, we have the San Andreas Fault, which is one of the biggest fault lines in the entire world, runs across the back corner of this property. And so we've got to be, we're engineering towards that. Here, you guys will probably be 200 mile an hour hurricane winds as well.